Today is a sort of harikatha style. We are not going to write any programs. I would like to look at some fundamental aspects of professional programming. I think this is the first of those sessions. We would like to look at that. We did write one stack program in the last session, v5.c, which actually works. I mean, there's nothing wrong with that program. It's definitely, it works. You can try it. Probably some of you have tried it on the machine. It works. But our interest in life is not just to write C programs that work. We would like to write C programs which are professional. Correct? And one of the main aspects of professionalism is maintainability. Maintainability refers to changes, ease with which you can make changes in the program when the specifications are changed. Question is, what are all the specifications which are going to change in that particular program? Of course, stack itself is a very simple data structure actually. Really speaking, does not deserve all the attention that we are trying to give to the stack program. But then really speaking, this entire discussion is common for all the future data structures. So whatever lessons that we are going to learn today, we would like to employ for all the future data structures that we plan to develop. So I'm just using the stack as an excuse. Because stack after all is a very, very simple data structure. In fact, there are only two operations. The two operations of the stack, we had the post increment store for the push operation was a simple stack square bracket sp++ equals something. So that was the push operation. And the pop operation was something equal to, we didn't even say something equal to, we just push it as a parameter, stack square bracket minus sp, pre-decrementary. So these are the only two operations on the stack data structure itself. Stack on array, stack on static array that we had. We can very easily have a stack on dynamic array, stack on stretchable array. We stretch it by reorder quantity. All that we can just think of those additional extensions of the program as exercises and do it on the machine. That is not the issue. I know this is a very simple data structure, but then we would like to look at true maintainability of programs and see how people build up professional C programs out of practically thin air, I mean, that's what we like. This is thin air. I mean, that's all that is there in the stack data structure. There are only two statements or two expressions that you have, which is doing the actual stack operation, which is the push and the pop operation. These are two statements that you have. And then we would like to we'll beef it up this into a professional looking piece of code is the objective of this particular discussion. We'll actually get to write that program only in the next session. But however, I would like to ask all the embarrassing questions today and see what are all the things that we are looking for in a true professional program. In terms of maintainability, what are all the changes of specifications which our friend is likely to ask for, the user is likely to ask for. Here, I said number of items. First, the question is, supposing the number of items, which is actually the maximum number of items that you can have concurrently at any given point of time in the stack. That is the first question. Supposing that changes, what are all the changes that we need to make to the program is the first question. That anyway, we've made it a very, very simple affair because we have got one symbolic literal, which is the capital and max. You can just change that value. All you need to do is to recompile your program and that works. Of course, if you had a dynamic array to start with, even that was not required. You could change the number of items. N max would become a lowercase n max, becomes a symbolic reference. You can accept it from the user saying, tell me what is the size of the stack that you would like to have. And I will give you that array size. This is not a big problem, right? So we can definitely do the change on the existing. See, v5.c that we have definitely answers the question of maintainability with respect to the number of items. There is no questions there. It is simple. It's been designed in as part of that. It is the other questions that I've got here which are much more important. The other three questions I've got. They are the three key questions on any kind of data structure program that we would like to develop. First is the data type itself. Fellow says, hey, your program is very nice. I started using it. It works. It's nice. I like your v5.c. But only thing is, no, I didn't want integers to be in the stack. Can I have double precision numbers? I would like to enter some fractional information also. Can we have doubles? So what are all the changes that you have to make if you want to change the int data type of the data items to double? So of course, we had one declarative statement which was the int stack square bracket n max. I suppose that will have to change. So this will undergo change, correct? This int has to be changed to double because that's the data type array allocation which was done by the compiler. We will definitely change this data type. And in fact, these assignment statements here, actually what you have is a couple of assignment statements. Now instead of copying an int into the stack array, you'll have to copy a double every time. So obviously, this has got to be modified to double. So this is one change. Simple. Anybody can make. No problem. And there's one more change. Don't forget we had this printf. Printf double quote %d backslash n comma this pop value, whatever that was. So now this %d backslash n was used because we had a 2's complement integer int as part of the array in the stack item, and we wanted to convert that to a series of decimal digits. Therefore, we had to use the %d as a conversion parameter to the printf. Whereas when you say I've got now this is going to be a double, definitely %d backslash n is not going to work. You'll have to change that to probably you can read the manual page of printf 3. Probably %lf I think is what something like that you will have to employ. You will have to change the formatting. You will have to change the formatting of the data. Conversion from int to decimal digits is different from double to decimal digits. Definitely you will have to change that. And one last thing is the reverse conversion. We use the ASCII star p to convert a ASCII set of digits which are typed into the line of characters into an integer, 2's complement integer. Definitely this has got to be modified because we want to convert that now to a double precision number. Perhaps you may have to change this to ATOD. ATOD is ASCII to double. It's available, it's part of the C library, so definitely you can do that. I think with these three changes, if you run your v5.c, that definitely answers the question of change of data type from int to double.